Excuse me, Professor.
Thank you. Thank you. Appreciate it. Thank you. Thank you. I'm sorry about that. Sorry about that. I didn't realize that I was muted. So, nevertheless, I was saying that, let me start again. Welcome to our weekly pre-lab session. Today's lab is on preparing a power solution and determining the pH of a power solution. It's a continuation of last week work anyway, still on acid and bases. All right. If you have mastered the concept of the pH calculation, then power solution shouldn't be that hard for you to really complete it. What I was saying is, as far as the semester is concerned, it's almost we are almost getting to home stretch, and I want to make the quizzes available so that you can get done, as early as you can. For number 8 and number 9, I'll make it available before the end of this week, and as soon as you get time, please. Do those quizzes, you realize that we have, after today, we have about 3 more labs. And if we can get done with the work as early as possible, and then the last week will be, you don't have too much work. I know you are taking other courses, and if we can get done with quizzes, that will be fine. You'll have time to study for or review for other courses. So let's see. Let me just share my whiteboard here and walk you through what we're gonna be doing. First of all, what is a power solution? A power solution, all right. Power solution is a solution which receives change in pH. A solution, all right. A solution which receives change in pH. Solution that receives change in pH. All right, a solution that receives change in pH is called a power solution. When you prepare a power solution, you use a weak acid and its conjugate base. So, made up of this is usually made up of what? Weak acid. All right, weak acid and it's conjugate what conjugate pills, and they must be in equal concentration to resist change in pH. All right. Common power solution you will see is the acetic acid. All right, acetic acid, COOH, and its conjugate base. Its conjugate base is the acetate ion, and it will look like this: CH3CO O, and sodium is just only to balance. When it ionize, it will generate the conjugate base. It should have equal concentration, all right, 0. What, 0.1, 0.1 molar, 0.1 molar, equal concentration of conjugate base, conjugate acid. Oh, something is going on today. Somebody say that they cannot see the whiteboard. Thank you. Right there. That is the whiteboard right there. So what I was saying is an acid, or rather the base or power solution is a solution made up of weak acid and its conjugate base. A solution made up of weak acid and its conjugate base. I see a question in the lecture saying which one of the following will you use to make a power solution, and you are presented with A, B, C. If you don't know the difference between a strong acid and a strong base, you will pick any multiple choice and think that this will make a power solution. Power solution is made up of a weak acid and its conjugate base in equal concentration. And the resistance in pH is designed in such a way that if you add H hydrogen ion, it will be neutralized by the conjugate base. If you add OH, it will be neutralized by the acid, and you will not see any change in pH. That is how the pH receives change. All right, change when you add a strong acid on a strong base. The acid is neutralized by the base in the solution, and a base is neutralized by the acid in the solution. Now, last week I walked you on how to calculate the pH. Everybody knows how to calculate the pH. Given the concentration, you say negative log of the concentration given in there. For a powder solution, the easiest way is using Henderson-Hasselbalch equation, and this equation. Should have written this in the pre-lab. pKa plus the concentration of the base, that is the conjugate base, of the concentration of the conjugate acid. A for conjugate, this stands for conjugate base, all right? And this is acid. I meant to say this is acid, A for acid, and this is the conjugate base at the top. So you have to understand what goes at the top, what goes at the bottom. Here, this is obtained from negative. pKa is given by negative log of what? Negative log of Ka value. Just to give you an idea of how do you get the Ka from, pKa from Ka, because in the quiz, I may give you the Ka value. How are you going to determine the pKa for your weak acid? This is the Ka. Ka is just acid dissociation what? Dissociation constant over weak acid. Literature values, we have literature values for different weak acid. You'll be given for that. But remember how to navigate, how to change from Ka to pKa in such a way that if I know the Ka and I know the concentration of the weak acid and I know the concentration of the weak base, I can find the pH of solution. In that case, the powder solution. All right. Now, when preparing a powder solution, always a weak acid whose pKa is closer to the desired pH. What do I mean by this? Say if someone asks you to prepare a powder solution whose pH is, say, for example, if I give you 9.8, for example, 9.80, you will determine or you will look for a weak acid whose pKa is closer to the desired pH. There is no way you can use, a weak acid whose pKa, if pKa is equals to, say, 2.85 versus pKa of 9.70, you will pick this to prepare a powder solution of 9.0 because it is closer to what you are, closer to what you are looking for. I've seen questions saying that which one of the following weak acid will you prepare a powder solution of APC, and you'll see the value and compare with the pKa value. Or maybe if you are given the Ka value, then you have to convert it to what? To pKa, and then you compare. That way it will tell you which candidate, which weak acid are you going to use. The closer the pKa value to the pH value, that's how you will proceed. Otherwise, it's not any weak acid you're going to use to prepare the powder solution. That's just a general knowledge you need to know as far as powder solution preparation. And this is called Anderson-Hasselbalch equation, this one. Sometimes, if I have volume at the top and I have volume at the bottom, volume will cancel out. So some problems may call for, or you are given masses of, reagent or acid in that case. It turns out that this is also true. You may want to look at what you are given. This is also true. pKa, all right? pKa plus number of moles, all right? Number of moles of base, of number of moles of what? Number of moles of acid. It still works the same way because molarity is number of moles over volume in liters. All right. So if volume is 100, 100 and 100 will cancel out, and also these equations work fine in some problems. That's how to find the pH of a solution, or a powder solution rather. Any question? Any question using this equation? Before I just zoom to what we are going to do today. All right, let me see. Do we take the log of the concentration? Log, yes, log, yes, you're right. Let me see, log of, this is going to be log. Yes, log of concentration. This is log of this, yes. You're right, yep. Log of concentration for powder, Anderson-Hasselbalch equation. Anderson-Hasselbalch equation, it is the log. Yes, you're right, Cynthia. You take the log of either the number of moles or the concentration for Anderson-Hasselbalch equation. Any other questions before I walk you through the simulation? Make sure you have the right equation for Anderson-Hasselbalch equation. Yes, you take the concentration. It is log. So here is the log, not concentration. Here is the log. Here is plus log of, and also for this is plus, to be clear, plus log of for Anderson-Hasselbalch equation. Log. Any other question? All right, let's move on to, if there's no other question, I want to pull the simulation and what we'll be doing in each section. All right, this is not what I want. Let's see, is it not? I want a simulation, and this is the site for simulation, and make sure that, if it doesn't play, I may want to, I may go ahead and embed on Canvas. Last week, somebody had problem playing the Adobe Flash on their computers, but mine will just automatically load, all right? I have the preset. If you look at the data sheet, I have the preset values for the targeted pH, let me just move this chart feature right here and take this across here. If you look at this pH value with the red arrow, all right, with the red arrow, this is the targeted pH. On the data sheet, I've given you in part one, all right, this is part one. I've given you the targeted pH value, 3.78, I believe. The second one is 6.11, and there is 9.67, and I think 10. We have I think 9 or 10. You will look at the yes, 10.5, 10.5. Those are the targeted pH values you will be using the new target here until you get those values before you adjust your concentration on Anderson-Hasselbalch equation. So if I'm looking for, if this is the targeted value, all right, if this is the targeted value, this is what I need to adjust the acid and its conjugate pace. This is the pace, and this is the acid. I will adjust the concentration until the blue line are in line with the red, that, or in other words, the pH for the blue should read red. Adam, how do we enter the pH target? Yes, that's what I'm gonna show you. Hold on, I'm gonna show you that. This is what I want to do. For this one, if this is the pH target, right? I'm just gonna adjust this and see how it's going to change. You see, it's changing until if I don't have any more, and then I may just want to adjust until I get the new pH. You may want also to use, you know, if this is the pH, look what is happening. What I was telling you, the pH should be closer to the pKa value of your acid. pKa value for this is what is selected here, which means, let me just move this out of my way. Hopefully it's gonna allow me to, where is it? Yeah. If you look at the pKa value here, it is way off 38.4. So that's not the right candidate. You're gonna check which one is closer. Maybe this one. Let's try. Maybe this. Well, right there. Yeah. So it changed, and then you now adjust this to, you know, until you get that. You see how it goes. 8.4. Maybe changing this. Yeah, like that. So that is the target. You see now the pH this is the target. 8.42, this is the pH. It tells me the concentration of what? The concentration of my acid and its conjugate base. This is the acid, this is the base. All right, this is the acid, this is the base. With that, you will fill on the data sheet. You cannot see from there, I don't know, you know, the background. Yes, there. You'll fill on the data sheet here the conjugate. See the concentration of the weak acid. This is the weak acid. Look at the screen. This is the acid. I'm just gonna put it on the data sheet, the concentration. It's now 0.96 molar. For the base, I'm just gonna put it in there. Identity of the weak acid. That is what you're talking about. Identity of the weak base and their concentration. This is what I'm using. This is what I'm using. And then Anderson-Hasselbalch equation, you know what it is. All right. Anderson-Hasselbalch equation, you know, pH, we just went through that. You will use that for your calculation, Anderson-Hasselbalch equation. And remember the significant figures with respect to pH. Now, coming back to you, Adams, All right. Coming back to you, Adams. How do I get a 0 point new target? You have to use this until you get the 0 point. You see how it's changing? New target, new target, new target. It's gonna change until you get that 9 point, 3 point, 3 point until you get the new one, the new target. So if it is 3.78, I think it is closer to this one. The reason why I can't get with this is because I'm trying to use this with pKa is way off. So if it is Adams, if it is 3.78, the conjugate acid-base pair I need to use is this right here. So I'm just gonna come there. It is closer to the desired pH. Otherwise, if you don't adjust here, it's gonna be very difficult to get the target to get the targeted pH. So having that problem, maybe with the new target, you can get the pH, new pH target 3.84. So it doesn't seem to work for that. 3.56, 3.56, 3.78. You click it probably like 50 times. New target. If it doesn't give you the new target, if it doesn't give you the new target for you to get the targeted pH, all right, I will look at this. Let's say 3.75. You don't need to, because it's just like, say for example here 3.75 for this new target, right? It's a function of this and adjusting to where you want to be. With this, you can see this. It's just a function of this one to adjust to closer to. And then these two will determine, not necessarily that I want this to go to, 3.78 and then I synchronize. Adams, I don't know if this makes sense, that the top part does not necessarily need this to be 3 and then I adjust that. I'll have just to worry about this closer to the desired pH. For example, right there, I can just go there and adjust this, it will just change. You see how it's changing? Like when it's closer, once I get that, and then I'll just have to worry about these two guys right here, without necessarily saying new target, new target, new target, and then you again adjust there. What I'll worry is only the top part right here and the concentration of, concentration of the conjugate acid-base pair. So the new target might just be like when I pick, all right, when I pick, say, what am I looking for in the second one? Let's see, say 6.11, 6.11, the closest might be the second one here. Let's click here, and it is taking me to, 5.99. Let's just forget about this, 5.99. You can now adjust this, and it's going to, to change the pH to whatever. You see how easy it is to encompass what you're looking for? Once you pick the weak acid conjugate pair closer to your desired pH, I think with adjusting the concentration of the weak acid and conjugate base, you can easily get the concentration, because it doesn't really matter whether you click 50 times and this red. In the long run, you will adjust this blue guy by moving up and down the concentration of the weak acid or the weak base. Does that make sense, Adam? Without trying to adjust the red one first, and then you go again and adjust here. What I'll just paste on is the conjugate acid-base pair closer to my desired pH. I'll pick that and then just vary the concentration here. You can't miss the concentration of your weak acid and a weak base to give you that. All right, let's say if I want 10.7, right? I'll just say 10.7 maybe is closer to this, the last one here. Hopefully that is what it is. If I click here, it is 10.2. So I'm just gonna change this to whatever number. You see how the numbers are changing, and it's just, I don't have to click 10 times. That is how you can use. If I want 9.58, say 9.58, maybe it's closer to there. All right, 9.58, and then I'll change that to, whatever number you want. And I think that will be much easier to, find the concentration of the weak acid weak base. Does that make sense, Adams? Just make sure that we are all on the same page. So I see that there are only 4. Yes. Don't worry about the red line right now. So the pH given value for the correction adjustment line, not the red line. Yes, the blue one right here. I already given you the target. So why will you want to get to 3.78, yet I've given you already 3.78? It's just redoing the work. You see what I mean? That way, it make your life easier. It make my life easier because anybody can pick any value on the red line, but I say everybody should work 3.8, and and I give you the criteria by which you pick out which conjugate acid base pair, because somebody, if I'm looking for 3.78 and somebody is using this one, it's not gonna work, because you try to go up, it's not coming down, it's not coming down to 3.78 or whatever you're looking for. I think that makes sense. Good? Are you on the same page? All right. I see. Thank you. Thank you. Any other question on part 1? So the values, there are only 4. Yeah, you are right, Cynthia. You have 4, and in 4 tables, I've given you on the data sheet. Please, if you have your computer, I know maybe somebody is using the cell phone. I do have on the data sheet preset values: 3.78 for table 1, for table 2, 6.11, for table 3, 9.67, and for table 4, 10.50. So those are the targeted for only 4. It's not everything on the table, right? Yes, to answer your question, Cynthia, you are asking which acid are we going to use? To answer your question, you will use, remember what I said earlier on, that if you are asked to prepare a powder solution, you will use, or you will choose an acid whose pKa value is closer to the desired pH. If I say, I want you to prepare a powder solution whose pH is 10.57, all right, 10.57. We are looking for 10.57. Again, I say 10.57, Cynthia. Your question is, how do we use the acid base pair? Yes, the pH, the targeted pH will tell you which pH or which acid base pair you're going to use. I picked 10.57 as an illustration. Let's see. If I pick the first one, look here, Cynthia. If you pick the first one right here, the pKa of this conjugate acid base pair is 3.74. And if you try to find the concentration here, it's not gonna work. You see, there is no way you will ever get closer to 10.57, which I'm looking for. So how will you choose that? To answer your question, you will come at this column right here. Look at this column, the pKa value. You will pick an acid base pair whose pKa is closer to the desired pH. All right? That is the criteria you're going to use. That is the criteria you're going to use. So remember, in my illustration, I'm looking for 10.57. So the closest one is this, the last one right here, which is this right here. Look at what is happening when I click this. The pH will, or the blue line will, the blue arrow will just jump to what? 10.3. I'm looking for 10.57. So it's much easier to change the, the concentration of the base and acid, concentration of base and acid. I think we may want to work with 1 decimal point. Let's work with 1 decimal point. I'll correct that. I'll refix the data sheet because I see here it is, I paste on 2 places of decimal on the data sheet, and it's gonna be very difficult for you. Let's work with 1 decimal place. I'll refix this. So 10.57, let's say 10.6. We're gonna adjust that to, all right, to 10.6. Yeah, 10.6. I couldn't get 10.57. It's only to 1 place of decimal, so all of them should have a pH of targeted to 1 place of decimal. I'll change that and do that. Is that clear, Cynthia? Does that make sense? Does that answer your question? Cynthia, are you there? Yeah, you say you don't see on the data sheet. Let me see, maybe I didn't post. Let me make sure. Let's see. Let me see. I'll repost it again to reflect what I just made that correction. If I go back to, you go to the assignment, let's go to assignment. I'm just gonna check in a minute if I made that changes. If you go to assignment and go all the way to the data sheet, this does not look the same on your end, but for my case, yeah, introduction, I need to post that. It's gonna be posted. Maybe I put it on the assignment. I'm just gonna post that in a minute. All right, with the targeted. Thank you. I'll just give you that data sheet. It is on my desktop. I'm using my Mac right now, but you will have on the data sheet those targeted values. Don't worry about right now. Once I post the data sheet, right now, I haven't made the folder for, I thought I did last night. Right here, look, for lab number 9 will be down here with the instruction and all those targeted pH values. That will take care of part A. Any other question? I'm gonna make correction on the data sheet. I do have those values on the hard copy. I thought I posted that. I'll post that immediately after the lecture so that you can get started with that. All right. Any other question? If there is no question, I want to go to part B. It's the same thing, It's the same thing as, all right, as part A. It's the same thing as part A, all right, except, what we need to do is do the calculation. Let's see. What we need to do in part B. That was part A. That was part A here. All right. This is the targeted pH, by the way. It is on the document, same day. It is on the announcement section. I thought I put it on the folder. It is on the folder. So let's put here 8. I'm just gonna put 8 there. I'll change that and to reflect 1 significant. So put there 6-1. At least you'll see with 1 place of decimal 7 there, not 2, and change this to 5 like that. And that will be for part A. For part A. Any question on part A? If there's no question, part B is similar to part A. except this time around you are given the concentration of the conjugate acid base pair here. And your job is to identify which one is the acid, which one is the base. All right. What will be the expected pH value on this concentration? Using Anderson-Hasselbalch equation, you plug in the concentration and you get the value, right? This is calculation, and please show your work. Express your final answer with the correct number of significant figures. Go to lab number 8 and see how significant figures and calculation with respect to pH. And then the simulation here is the same as, you see, this is, if I'm using, let me just use a simulation here of 0. I'm going to use 0.7, all right? I'm going to use 0.7, 0.68 and 0.68 and 0.68 and 0.43. I'm gonna change this to 0.68 and this is 0.43 on the simulation, and this is where you will put. So if I go here, let's just go back there. It's the same thing. Remember, this was HPO, this is the acid. All right. So if I change the concentration to 0. This is the base, no, the acid, 0.68, let's see, 68, right there. I'm looking for what the instruction says, 68. Yes. Oh, no, I didn't mean to say 7. 8. And then 0.43. I'm just adjusting to 0.43, 0.43. Yeah, these are the concentration given now. The one bolded on the data sheet, these are the concentration. What is the pH? This is the file you will be, you will be recording down, and then you take a picture of, this screen and attach to your data sheet. You may not really attach, but if you just, put below, it might not really fit in the box. Some of you, I saw you are able to fix it in the box given on the data sheet. If not, you can just attach it below, and that is fine. That's what that's all what you need to do in part 2. Calculating the pH and doing the simulation and taking a picture and putting it in there on the data sheet. And that's all for today. All right, and I think we have 1, 2, 3. All right, we have 1, 2, 3. There are only 3 activities for part 2. 3 activities for part 2. So Sylvia, I think I put it on the announcement, the data sheet, and I'll make a note of that so that you have 1 decimal point, not the 2 I had initially on the original data sheet. Any other question? Any other question? If there is no other question, I will stop sharing the screen, and the class is dismissed. We will meet again next week. Remember, there will be 2 quizzes posted. This is quiz 8 and 9. It's still on acid and bases. I don't know if it's gonna be at most maybe 20 or less than that multiple choice question will be posted on Canvas. Continue working on the lab number 9. Hopefully by next week you will turn in. Otherwise, thank you. I'll see you again same time next week. Be safe, stay healthy. Thank you.